Hi everyone, welcome to the Earth Science Regents Review podcast series created by Homix Middle School Earth Science Department. Today we're going to be talking about sedimentary rocks. Now what's important about sedimentary rocks is that there's actually three types of sedimentary rock that we're going to talk about. The first type are going to be the rocks that are made of other rock fragments. They're called clastic or fragmental. Next we're going to talk about the rocks that are made through chemical precipitates or chemical evaporites. They're going to be your crystalline or chemical rocks. And finally we're going to talk about the rocks that are made from dead plants and animals. Those are going to be your bioclastic or the organic rocks. Now, your classic rocks, which are going to be the most common type of rock found at the surface, is going to be very, very important because there's a lot of features in this rock that are unique to sedimentary rocks, which we'll talk about in a little bit. These rocks, because of the features that are found in them and the process they create them, they're going to be the most common type of rock at the surface. They're going to make a very thin shell around our entire planet. Now, what's important here is to understand the way in which classic rocks form. Larger rocks need to be broken up. That's what we call weathering. Those broken up rock fragments need to be moved. That's called erosion. The most common type of erosional agent on the planet is going to be water. Now those broken up rock fragments are called sediments. Eventually those sediments, after being carried a long distance, they get dropped off. That's called deposition. Okay, once they get deposited, those sediments tend to get buried. Now the more layers of sediment that you get, the greater the pressure underneath the surface. That pressure, called compression, is going to cause compaction of the sediments, which means those sediments get nice and close together. Once they get close together, then they're going to get glued through a natural cement, okay, or another term that we use is what we call lithification. So you can see that your clastic processes are extremely complex here in regards to what a classic rock has to go through to become a clastic sedimentary rock. So what's important here is to understand that classic rocks are organized by texture. We have 5 rocks. We have conglomerate, breccia, sandstone, siltstone, and shale. They're all organized by the size particle that's going to get glued together. Now all 5 of those rocks I just mentioned are going to be polymineralic, which means that they're going to be made up of many minerals. So let's take a look. You notice that your conglomerate is made up of rounded fragments. Your breccia is made up of angled fragments. Okay, the big difference here is that the rounded fragments have been carried a further distance. When particles get carried a far distance, they tend to get rounded out quite a bit. So that's a big difference between those two. Then we're going to move on to sandstone. Sandstone is made up of sand-sized fragments. Okay, sandstone has a very gritty feel, almost like sandpaper. Then we move into the 2 rocks with the smallest fragments. Shale is made up of clay, and siltstones can be made up of silt. Okay, those 2 rocks are very hard to identify because their particles are so microscopic. So very important to understand the 5 classic rocks that are found in your reference table. Well, that brings us to the features that are found in classic rocks. So we have fossils, okay, which are the remains of dead plants and animals locked up in the rock. We can find mud cracks, okay, which are going to indicate that water might have evaporated very quickly from an area. We get ripple marks, which indicate that maybe we had a shallow sea or maybe even a desert in the region. We also have layers. Okay, the horizontal layers of sediment, a very, very key characteristic here. Now, it's nice to know that there's a little bit of a difference between your sedimentary layers and your crystal bands. Now, let me explain the difference between the two. The rock on the left is a sandstone that has definitive layers. Those layers are all made up of sediment, broken up rock fragments that were probably deposited either by wind or water in a horizontal fashion. The rock on the right, that's a metamorphic rock called gneiss. That has crystal bands. Those bands were created through the recrystallization of the minerals that reorganize themselves within the rock. That has a special texture called foliation. So very important to understand the difference between your sedimentary layers and your crystal bands. Okay, very important to know those. Now, those features are important within a sedimentary rock, very simply because they tell us a lot about the environment in which they were created. If you have ripple marks, if you have mud cracks, tells a geologist a lot about what was going on while that rock was forming. Now those features are unique to sedimentary rocks because igneous rocks, those features would melt, and metamorphic, those features in those rocks would get crushed. The second type of sedimentary rock are what we call chemical or crystalline rocks, and they form through 2 processes. The first process is what we call precipitation. Basically what happens here is too much of an ion tries to dissolve itself into water. Okay, what happens here is that when water dissolves a substance, that's what we call a solution. There's only so much room in the water for water to dissolve a natural substance. Once that becomes completely filled up with the substance trying to get dissolved, we say that solution is saturated. If there's too much of an ion trying to dissolve itself, eventually it's going to fall to the bottom of a lake or a stream, or maybe an ocean or a sea. Eventually all those ions will eventually crystallize into rock. That's what we call precipitation. Those rocks are called precipitates. The second type of process is what we call evaporation. And basically, like I said, water is a very good dissolver of substances. So what happens is water tends to have dissolved mineral matter in it. Water will evaporate off, but the substance that's dissolved in water does not turn into gas. That's what evaporation is. So that substance is left behind. So basically what happens here is that water turns to gas, leaving the solid behind. That's the process of evaporation, and the product left behind is called an evaporite. Okay, so here's a couple of our chemical rocks. They tend to be monomineralic. Rock salt is made up of halite. Limestone is made up of calcite. Dolostone is going to be made up of dolomite. And rock gypsum is made up of the mineral gypsum. So you can see that the names of the rocks kind of correspond with the mineral that makes it up. So the last type of sedimentary rock that we have is what we call a bioclastic, or your organic rocks. And these can be made from the dead plants and animals. Okay, these also tend to be monomineralic as well. Okay, now the two rocks that you really need to know are coal, which is made up of dead plants, and limestone, which is made up of cemented shells. And you notice limestone is also in the chemical section as well, and can actually be made by two processes, either through the chemical precipitates or it can be made through the cemented shells. So realize that that rock has two ways in which it can form. So it's going to be very important that you understand page 7 in the reference table, your sedimentary rock chart. So with that being said, good luck, and we'll talk to you soon. Goodbye.